Okay, today I would like to make a piece, something looking like these, but much more simplified one, but using the same concept. I believe these models are called digital grotesques made by Michael Hansmeyer. I believe these are made with pretty simple recursive mesh editing procedures, like in a fractal way. Frame by frame, it's subdividing the mesh and adding some new faces to the mesh and modify its vertices by some criteria. And if you continue doing that, you'll get something like these. But I believe it's gonna take so much time to create this kind of grotesque mesh, but with the simple rules, just a few frames, I believe I can create some simple mesh with the same concept, but still looking interesting. So let me try doing that. Okay, so I would like to start from a box and use that box to subdivide frame by frame and modify its vertices by some algorithm. And let's see if I can make it like an interesting shape. Let's name this G1, and so I have the polygon mesh for a box. And first, let's see if I have a normal vectors, and I would like to normalize it first. Its point, so that each point will face the normal vector of each point will direct orient from center to outside. Okay, next, in order to subdivide and modify these vertices, I need to have some criteria in order to move these vertices. So I would like to attach some info, metadatas to this mesh. I mean attributes. So let's give this mesh a area. So if I go see the geometry spreadsheet, I will have an area for each faces. Now if I go look into the point attributes, I have the points and the normals, and I also want some IDs for each point, and I'm gonna use that ID to color the mesh later on. So let's give a point wrangle, and let's give an ID 0 as an initial value, and also let's give a detail attribute, last ID same 0, so that I could use this info, last ID, to see what current ID am I in for each frame. And if I look into the geometry spreadsheet, into the detail, I have last ID and the point ID 0. Okay, and let's name this attach ID. Okay, next let me have a average of these areas. Well, right now it's all 1, so it's gonna be 1 for sure. But I want to give the average area of these faces to detail, so that I can use that later as well. So let's give a there's no detail wrangle, so I'm gonna just give a point wrangle, and I'll make it detail, and I'll name this area update. Okay, and let's give a average area. Let's make a variable average area and set it to 0, and look through all the primitives, faces of this geometry, and get the area I have just measured using the node, using prim from 0 area I, and add this area to the average area, and last of all, divide this average area by the number of primitives. I think I need to convert this into float so that I won't get the integer result. And primitives, and give this value to detail. And let's see if I have it on the detail. And if I look at the geometry spreadsheet, I got the average area on detail, so it's good. Okay, next. And next thing I would want to do is to use these areas, average areas and last IDs. But before doing that, I would like to make a simple definition to subdivide and subdivide these geometry by, let's show the edges. I would like to subdivide this mesh by adding a center points on the centroid of each faces. So right now I have 6 faces, so adding 6 points to each face, the center of faces, and make a triangle face from the corner of faces. So if I add the points, I'll have 4 triangle faces for each primitive faces. So I would like to make a wrangle doing something like that. So I want to do it for each faces, so I want to use primitive wrangle. And let's see, first I want to have the centroid of each faces. So let's make a definition first, function first for the getting centroid. So I'll name it get centroid, and what I need to input is the list of vertices. If I have this face, I'll have 4 vertices. And the centroid, first I make a empty variable called centroid, and I'm gonna return it. And let's do a calculation here. So for I, gonna go look through all the vertices and get the point number for each vertices using vertex point. And next, get the position of the point using point. And add each position to centroid first. And on the last, divide the centroid by the length of vertices which should give you the centroid point position of each faces. Okay, now let's make another function to add a point. Also I add the triangle faces. Let's call this void add point, and I'll have an input vertices and the position of the center point. I mean, it doesn't have to be center point, but the point to be added on the faces. Okay, now first let's add a new point to this point position, and let's call this new point. And I'll be having a new point with this, and let's give this new point a new ID, and I can do that by set point attribute and new point, which will be the ID that's one larger than the last ID. So let's make a new ID here. First get the last ID from the detail attribute and increment it by 1, and use that new ID for the new point. And let's also set the detail attribute yourself, the last ID, to be this new ID. Alright. And let's go through all the vertices. And let's make a primitive, a new triangle faces. So in this case, I have 4 points for one first surface, one face. And for 4 points, I'll have 4 triangles. So if I have 4 points, I'm gonna make 4 triangles here. So in order to make a triangle, I'll need 3 points. One is the one I already made, is new point. The other one will be the point that is already in the faces, which is from the vertices. So the first point will be vertex point yourself, and let's use the first one to be the index of I. And the second point will be vertex point yourself, vertices of I plus 1, and modular it by length of the vertices. Okay, and finally, let's add a triangle primitive, and let's call it new prim equal add prim yourself, and let's make it poly pt1, pt2, and new pt. Okay, it doesn't give me error so far. And finally, I have to call these functions. So first of all, let's get an current area. For each faces. And also, let's get the average area as well. From the detail attribute. Okay, and I would like to make a condition when it's gonna be divided, when those faces gonna be divided. So I wanna make a condition something like this: if current area, which is the area of this face, is larger than the average area, which will always be 1 for this box. I'm never gonna update this average area anymore. So it's always gonna be 1, but the current area will gonna change by modifying the position of the vertices for each frame. So if the face got bigger than 1, then let's divide this mesh surface mesh. So I have this condition, and first of all, what I need to do is to remove the base face, since I'm not gonna need any more these squares, but I will have a new triangle faces. So first I'll remove the face by using remove trim, and also let's get all the vertices from the primitive. Okay. And now that I have the vertices for each face, I can get the centroid using the function I made before. Get centroid. And use that centroid at a new point plus a triangles. Now let's see. That's gonna do anything right now since I have this condition. Right now, both average area and the current area is 1, so it's not gonna subdivide. So let's comment this out to see if it's working. Yep, it is working. Yep. But I can see I have some weird like blackout or something. And I think it's because of the problem with the normal direction of this point. I guess it's facing inward right now. Not sure. But since it's having a problem on the normal direction on the center of the point I just added, so let me add a normal node here too, and for two vertices for the points, and now it's fixed. Okay, and I also would like to give a normal attributes for each primitives. I mean the triangles I just made. Right now I don't have it, so I'll give another normal. I'll just name this normal point, and I'll name this normal prim, and I'll set this to primitives. Now I get these normal info for each faces, and I think the normal direction of the points has been resetted, so I don't want to do that. I'll reorder the node like this so that I have both face normal direction plus the point normal direction. Okay, it's good. Now next, let's recalculate the area for each triangle, since right now I don't think it has the correct area. Right now it's saying it's all 0, so it's not correct. So let's measure again the area, and let's see if I get it. And yes, I get it, but the normal direction has disappeared. I need to preserve it, I think. And wait, it's been disappeared here. So I gave a normal point. Somehow it resetted the point, resetted the face attribute using these, and I don't want that to happen. Now, how can I preserve it? Seems like I don't have a way to preserve this, I guess. In this case, let's see. Let's cancel this. And let's give a primitive wrangle. And let's see if I can do like this. So the vector normal comes like this. And I have the primitive normals plus the point normal. I guess I didn't need to even do this, but just in case. Okay, and I have the areas for each faces. Now, right now the area is doesn't give you the boundaries, like what's the minimum, what's the maximum, and with this it's a bit hard to use it afterwards, so I'm gonna give a detail attributes the minimum and the maximum number of the area for all the faces. Okay, so I'm gonna have a primitive wrangle, and let's name this calculate area. And let's name this wrangle min area min max. All right. First, let's see if I want to add an attributes to detail, so I have to make a detail. And let's have the number of primitives first, and let's have a minimum number. Let's give an minimum number, something really big, and maximum 0. And look through all the primitives. Load area equals prim area, and if area is bigger than max, then feed max with area. If the area is smaller than minimum, then feed the minimum with area. Now I should get the minimum and maximum of the old areas. So use feed that value to a new attribute on the detail. Call area min. Oops. area min and area underscore max. Now let's check it. I go to detail. Yes, I get the minimum maximum. Right now it's the same numbers, but it's gonna give you the minimum maximum if when the vertices changes. And each area has each face has a different area. Okay, now I get the areas. I would like to have several more attributes in order to control the vertices. Now what else I can have? This measurement node gives you area, parameter, curvature, and volume. I guess I could use the curvature as well. So let's give a measure value and curvature, and right now it's from minimum to maximum is from 0 to 1000. It's okay with this for now, and I'm not sure if I have a. So I know that the maximum and minimum is in this range. And let's check it out. The curvature is on the point, which is said to be 0 to 4. It's pretty small. And I would also like to fit this number into some values. But the curvature is a bit tricky. If I do this from 0 to 1, it's not always correct. I mean, it seems like it's clamped out. So I want to do that. I'll give 0 to 1000 and I'll just divide it by 1000 later on. Okay, so let's name this calculate curvature, and I'll give a point wrangle. And I would just want to modify the float value on each point called curvature divided by 1000. Let's see. Yeah, now I have 0.004, which seems more correct than being 1. So that's good. Now, I can also use the height of the point as a driving force to move the vertices. So let's have a minimum and a maximum of these height as well. I'll just rename this curvature fit. And let's have another detail wrangle. Let's give from the point and name this detail. And let's do pretty much same with the one I did for the area. I'll name this height min max, and I'll just gonna copy the area min max x and I modified it a little bit to use it for the height. First I need to get the position of the point. So, and it's not for each primitives, but it's for each points. So I renamed this endpoints, and position for each point will be like this. And the height that I need is float height position y. And if the height is bigger than max, max will be this height value. If the height is smaller than minimum, then the minimum will be this height. And feed the detail attributes with height min and height max. And let's see. Oop. Yep, I got an error. And it's a spell mistake. Spell. And see, if I go to detail, okay, I got the height maximum 0.5 and height minimum minus 0.5. Seems correct. Okay. Next. Now, what else I can get as a driving force? I could also get how flat, how horizontal each face is. Like, for example, the face on the top of the box or at the bottom will be equal to horizontal to XY plane, but the one on the side is totally vertical. So I can name it horizontality. How flat, how horizontal is it? And use that to drive the vertices. Now let's calculate that as well. And I can get I can feed horizontality for each faces. So let's use the primitive wrangle and name this calculate horizontality. And let's give a new vector up, which is facing upward. And if I calculate this dot product with the normal direction of the face, then I will get how horizontal it is. So for each primitives, I will give a attribute horizontality with the calculated the dot product, absolute value of dot product between up and the normal of primitives. And let's see. Yeah, these are the ones. So 0 means it's totally perpendicular. And 1 means it's totally horizontal. And it seems correct. Okay. Now I think I have all the infos that I need to drive the position of the vertices. Right now I have 4 attributes: curvature, area, height, and horizontability. Now let's use that for attributes to drive the position of each vertices and move it frame by frame, and if the area is bigger than the average area, then divide it and continue doing that to make something interesting. Now, in order to do that, I need to give a modifier to use each attribute to move the vertices. So let's give that. And let's and I need to do it for each point, since what I want to move is the point, the vertices. So I'll give a point wrangle, and let's name this area modifier, and I'll copy paste this and name this curvature modifier. Again, copy paste, height modifier, and last, horizontal modifier. Now let's write some stuff for each modifiers. Now first, for the areas, what I need to do is to get all the areas for each point, but point doesn't have any area information. So what I need to do is to get the attached primitives to each point, which means if this is the point you're looking at, you'll be having 1, 2, 3, 4, 5, 6 faces. And I would like to get all the areas for these 6 faces and get the average of these faces. And that will be the area value for each point. Now, in order to do that, first I need to get the neighbor primitives using the point prims, and for each point. And I will give an empty variable called average area, and look through all the primitives that point has and get the area from the primitive, as I've been doing a lot of times, and add this to average area. And finally, divide this average area by lengths of the prims. Now I got the average area for each point. Next thing I should do is how much I would like to move using this area. Move the point, move its own point using this value. So I'll give, and the direction of the point that I want to move is gonna be the normal direction of each point, which will be this blue line. So I'm gonna use the normal times average area. And I got an error. It's because I didn't name it prims. Now already I can see that the point has been moved with the info that I have, the area info for each point. The problem is that right now I am not really controlling how much it should move, correspond to other values. Right now it's doesn't have any ratios, like how many percentage it should move compared to the others. So I would like to give a parameter for that as well. So let's give a null, name this controller, to have all the parameters that I need, and call it something like special, and let's give a parameter. Now this time I will be having I want to give a minimum and a maximum value, how much it should move. So I'll give this one minimum and maximum float parameter, and I'll name this area range. And let's say it's from 0 to 1. It doesn't really mean anything, but and do that for other 3 parameters as well, 3 attributes as well. One is height range, from 0 to 1, curvature range, and last, horizontal range. From 0 to 1. 0 to 1. Well, could be minus, but this range doesn't really mean for this parameter, I think. So I guess this is okay. Apply. And I have these attributes right now. Now I can copy this parameter and paste it to this reference as a reference, but yeah, I'll just copy this. Oops. And why I want to use this is here. Let's name this minimum area multiplier, and paste relative reference, and change this to CHF. And on the last, I want to put all these wrangles that I am making right now inside a solver. So the path's gonna change. So I'm gonna make it as a absolute path. something like this. And I have another value, max area multiplier. I can just copy this and rename here max. Oops. And finally, I want to modify this average area using the minimum area multiplier and the maximum area multiplier. So what I can do is to use fit. So fit the average area, which the minimum will be in the detail area min and detail area max, and remap this using the value I have just made, min area mult and max area mult. And it gives me an error, and it's because I don't have a bracket here. Okay, now the movement is more slight. It's just slightly moving right now. Last time I was drastically moving, but it's a lot of movement, and it's good because you don't want to see the changes so sudden. Okay, now that's it for the areas, and let's do the same stuff, pretty much the same stuff for all the other stuff: curvatures, height, and horizontal. The curvatures is much simpler because you already have a curvature value inside a point attribute, so you just have to get it. Like this. And as for the multiplier, minimum curvature mult, you can do the same thing with here. You can copy, paste here, and set this curvature range min. Also, you will need a maximum parameter, so name this max curvature mult and rename it here max, and remap the curvature using the fit. Now the minimum maximum is 0 to 1, which is I already set it before, so I don't have to get it from the detail. And the minimum, set it to minimum curvature mult and maximum curvature mult. And for this one, it's same as the height, the area. Move the point using the normal times curvature. Okay. I don't see any difference here because it's so small right now. Okay, let's next is the height modifier, and it's pretty much the same with the curvature. Since the point already has the height number, so let's get a point well, actually, the position is at P, and the float height will be position Y, and as always, give a minimum height multiplier and copy paste to 1 and rename this height range min, and rename this to maximum height multiplier, and to max. And as always, need to remap the height. And the minimum maximum is in the detail, so we'll get it from the detail attribute height min and height maximum, and convert it into between height minimum height multiplier and maximum height multiplier. And last of all, do the same thing for this as well. Move the point by normal direction times height value. Okay. And it's not moving at all since all the parameter is 0. So I can give some number to it to see if I have any difference. And I am not getting any updates. Seems not. And let's see why is that. This might be wrong. Oh, yeah, I needed to have a slash. Okay, it's a bit too drastic, so let's do it like this. And last, for horizontal. Horizontal is a bit close to area modifier since it has its attributes in the primitive, so let's just copy paste from the area and rename some of it to match. So I'll have average horizontal ability, and for each primitives I'll be having a horizontal from the attribute called horizontality and add each horizontal to average horizontal. And last, divided by the number of primitives to get the average. Now next, I'll have to get the parameter from the controller node. Let's name this minimum horizontal mult and maximum horizontal mult. and rename this to horizontal. And fit the average horizontal using the fit function. I already know the minimum maximum horizontability, which will always be between 0 and 1. So the source minimum and source maximum will be 0 and 1, and for the target will be minimum horizontal mult and maximum horizontal mult. And last, move the point by horizontal. Oops. And yeah, it's moving by its horizontability. It's moving its point. Okay, now I have 4 different modifier. And what I want to do with these 4 is to get all the point averaged out for each modifier. So each modifier gives you a different vertex movement. So I want to merge all the position and get the average for each point from these 4. Now, to do that, I'll give a point wrangle. And luckily we have 4 input here, so let's give all 4 values connected to each input. And now let's get all the vectors for each input. The first vectors will be just at mark P. Other one, I can use the point like this. I have a spell mistake. This one also. And I have 4 vectors. The final points that I want is P1 plus P2 plus P3 plus P4 divided by 4. And voila. This is the final result. Combining all these points position averaged out. Now, this is the base flow for the subdividing and moving the vertices, but it's just doing in one frame and it's not growing out. So what I need to do next is to give these flows inside a solver so that I can update recursively. Now let's do that. And from where I should do, wait, so this is given a point. Okay, so let's name this subdivide. And I think I need to give from below here to put it inside the solver. So let's give a solver and cut this out, paste it here, and feed it here. And activate the last one. And let's see. Now let's start from frame 0. And 0 doesn't give me anything. Somehow. The reason is somehow I'm not getting anything here. Ah, no, it has no. Oh no, should I just ignore the, what's the error? No top object name specified. So it's not getting any object on the 0 frame somehow. Huh. Weird. Let's see. Like this to 1. It does give. Let me try. Oops. If I have another solver, place it here. I do get the geometry. Oh. Then let's copy paste this. Cut this. Paste it here. And seems okay. Okay, and right now the movement is too big, obviously. It's just because the speed is too fast. Though it looks interesting, but a bit too fast, so let's slow it down by controlling the value of controllers, the parameters that I set. Now it's pretty big, these things, so I just want to make it something really small. Something like this, from 0.1 to minus 0.1. And yeah, how's this? Ooh, still big. And obviously, I need to, the subdividing is always working, so I need to add the condition here that I commented out before. Okay, like this. Now, let's see. Yeah, so let's try. Right now I have a weird blackout as well, so let's normalize it on the last. But it always gives me like this. That should be fine. Ooh. Yeah, the simulation fast is really fast, and it already gives me some interesting shape. Looks pretty interesting. A bit bolly, but and I can try modifying the parameters here to see what's the difference it could make. Yeah, it's from here you just need to modify some parameters to get the result you want. Maybe this height one could give a drastic change, I think. What if I give this to minus? Oh, interesting. Well, let's give it as a plus and okay. This looks pretty interesting. Let's have a little bit more speed. Maybe I could decrease this number and increase this one. Alright. Now, right now if I turn this shading to smooth, it's a bit hard to see the geometry, so let's on the last let's color it using the ID that I set previously. And first of all, let's look at the value that I have. So each point have its ID. And every time it makes a new surface, a new face, new point, it gives you a new ID for each point, like these. So I could color it using colored points using that value. And to do that, first I need to fit these IDs into between 0 to 1. So let's make a point wrangle. And the good thing is that I already have the maximum number of the ID, which is on the detail. which is this last ID. So I could just use that to get the value from 0 to 1. So first get the point ID attribute using something like this, and fit this value by divide this number ID by this last ID, and just in case convert it into float. Oh, doesn't work. Oh, the value itself is float, so I guess it's okay. And let's give a new value called color into the color attribute. So if I go and look into the color, I have the attribute col, and let's use that col value to actually color this geometry. And I can use the color and use ramp from attribute and use the col. Now it's already looking really interesting. But let's color it more interestingly, so I'll give this white and something blue here, and also something light blue here. And voila, looking good. And if I play this, it's a bit too fast. Let's make a flip book. Slowly grows by using the subdivision and moving the vertices by the driving forces set in the parameter. Yeah, this is it. Thank you.